Cheers and welcome back to Solar Phenom Training, where the smart get wise and the wise get wiser. This is part 2, solar PV roof design and sizing. This by far is the most important part of your homework in designing a system for your homeowner and offsetting their utility bill or totally eliminating their utility bill. So we've learned from our spreadsheet on our site audit form that this homeowner uses an average of 1,500 kilowatt hours per month. Their average monthly cost for that 1,500 kilowatt hours is $245, and their average kilowatt hour price is 16.4 cents. So let's figure out how we are going to offset their utility bill and size their system appropriately. And we're going to do it longhand way instead of using a proposal tool or a financing tool online. So at 1,500 kilowatt hours, if I want to offset this homeowner's utility bill by 80%, I'm going to take 1,500 and times that by 80%. So 1,200 kilowatt hours is what I need to produce this homeowner to offset their utility bill at 80%. So on average per month, there's 30.42 days in a month. There's 5.5 sunlight hours in the foothills and the valleys. There's 5 sunlight hours on the coast. And there's an 80% efficiency loss for the, 20% efficiency loss for inverters and other items that we can't control. So I take 1,200, I divide that by 30.42, divide that by 0.5 sun hours a day, divide that by 0.80, and I get a 8.96 kilowatt system. This is the size of the system that I need to install on the homeowner's roof to offset their utility bill 80%. Which means that 80% of the power that they are going to consume at this household is going to be generated by solar. The other 20%, they are going to go back to Edison and buy it at either a tier 1 price of 13 cents a kilowatt hour or 16 cents a kilowatt hour. My goal is to come underneath that. So I know that I have to produce on this homeowner's roof about a 9 kW system. A solar module is 40 inches by 62 inches, which is approximately 20 square feet. So now let's go to Google Earth and get to the nuts and bolts. This is the roof that I'm looking at. So I know that this is north, straight up on the screen. You can rotate this screen. You can zoom in, zoom out. You can adjust which way you want to go with the hand over here. You can zoom in and out with this button here, or you can roll on your track mouse. If you hold the shift key and use your track mouse, you can get right over the top of the roof, which is what you need to be accurate. Google Earth is accurate within 3 inches. So we are only trying to get a good understanding of the size of this roof without actually going and physically measuring this roof. So the first thing I do is I click the ruler. I make sure that I'm in feet. You can do inches, whatever you want, yards. So the first thing I'm going to do is I'm going to look at this homeowner's roof and go, and they have a nice southwest facing roof. So I'm going to click on this ridge and I'm going to drag my mouse down. And I know that this is almost 17 feet. And then I'm going to click on this eave over here, come across. So I'm at 17 by 46. So if I go back to my sheet over here, I'm at 17 by 46 on a west facing roof. 46 by 17. 46 by 17 46 by 17 is 782 square feet. 782 square feet divided by 20 square feet is our module. 39 modules I can fit on that roof. 39 mods. My azimuth for that roof, if I use the ruler again, I'm just going to drag it, put it on the roof and drag it, make it perpendicular to this eave line right here. My azimuth for that roof is 253. That's the azimuth for this particular roof. So I'm going to go back to my sheet. My azimuth is 253. I've already inputted that. So is 39 modules enough? I'm not sure. I'm going to go back to Google Earth and measure another roof. My next best roof is this south-facing roof right here. So I'm going to measure this roof. I'm going to go from the ridge down. So I'm at 12. And I know I'm not going to put any modules in this triangular area right here, just because it's too small for me to do anything in there. So I'm going to measure from that area right there in the valley out to the eave, which is 22 feet. I'm going to always round down because I want to make sure that my modules are going to fit, and then I'm not going to oversize the system, and when my site engineer gets there, he's going to tell me that the modules don't fit, and I'm going to have to re-sign the homeowner documents and possibly lose the sale because I wasn't a professional when I designed this system. So 22 feet by 11 feet. So I'm going to go back to my sheet. 22 by 11. 22 by 11 is 242 square feet. 242 square feet, 242 square feet divided by 20 is 12 modules. So I'm going to fit 12 modules on that roof. My azimuth for that roof, I'm going to go up to the ridge again, drag it perpendicular to that roof, and I'm at 161.9, so I'm going to round that up, and I'm going to be at 162 azimuth. So my azimuth is 162. So I'm looking at this going 39 modules and 12 modules for a total of 51 modules. My next step is to make sure that I'm not in a city that has fire code. I know from experience that Temecula enforces fire code. So fire code issues have to do with being able to place modules in a certain area. So fire code for particular roofs looks like this. So if you were to do a cross gable roof, which we need to stay 3 feet away from the ridge and 3 feet away from the eave line. On a cross gable valley roof, I need to stay 3 feet total from this valley. So if I go back to Google Earth, this roof right here, I need to stay 3 feet from the ridge, and I need to stay 3 feet from one of these eaves. So I need to deduct 3 feet from my ridge number and 3 feet from my eave number. So I'm going to go back to this sheet and I did this on purpose so that you could see that there was 39 modules that I could have placed on this roof, and if I didn't look into the fire code issue, I would have oversized the system and eventually ended up re-signing this homeowner. So I'm going to deduct 3 feet from that. I'm also going to take 3 feet from this number. So now I'm at 43 feet times 14. So 43 times 14 equals 602. I'm going to go 602, and I'm going to divide that by 20. So now I'm at 30 modules. So if I would have not done my homework, I would have actually placed 9 more modules on that roof, and it would have never fit. And it would have never passed plan check, and eventually would have never got installed on the roof. So 30 modules on that west facing roof. Now I'm going to go to the other roof, and I'm going to actually take 3 feet off that number. I'm going to take 1.5 feet off this number right here, because I need to be 3 feet total. I need to be 3 feet total and not in the valley with my solar modules. So 1.5 feet this way on this roof and 1.5 feet this way. So 1.5 4.5 feet there, 3 feet over here, so minus 4.5 feet going this way and minus 3 feet this way. So I'm going to go back to my sheet and I'm going to say this needs to be 22 minus 4.5 feet is 17.5. And this from my ridge down to my eave was minus 3, so that's 8. So now I'm back to my calculator. So it's 17.5 times 8 equals 140. So I just took 100 square feet off. So 140 divided by 20. So now I went from 12 modules to 7. So I can fit a total of 30 on the west facing roof, 7 on the south facing roof. So I'm at a total of 37 modules times 250 watt modules. 37 times 250. I'm at a 9.25 system. 9.25 system. I'm over the 8.96, which is what I figured out that I needed to offset their utility bill by 80%. So this looks good. I can fit 30 modules on the west facing roof, 7 on the south facing roof, for a total of 37 modules, 250 watts for a 9.25 kW system. My next step is to figure out what my tilt is. And a tilt is what the angle and the degree of the roof is. Can I figure that out through Google Earth? Absolutely not. But I know that 90% of the houses in California either have a 412 pitch roof or a 512 pitch roof, which is either 18 degrees or 22 degrees. So if I go to Google Earth and I click this little guy right here, I'm going to hold my mouse down and I'm going to drag it, and it's going to take me down to a street view of these homes. And I'm going to be able to actually scroll through and look at this house. Internet's a little slow today. So if I look at this roof right here, I know that this roof right here is the typical 412 or 512 pitch roof. So now I'm going to go back to my spreadsheet, which I'm going to actually go back to this spreadsheet right here. I'm going to put my array and azimuth tilt. So I'm going to do, so I have a west facing roof at 253. So 253 is my azimuth, and my tilt is 22 degrees. On my other roof, I'm at 162 azimuth, and my tilt is 22 degrees. The size of that system was 30 modules, 30 times 250. So I have a 7.5 system on one roof, 7.5. Number of modules was 30. The type and the inverters I'm going to figure out later when we get to stringing. This roof right here, my west facing roof, was 7 modules. So 7 times 250 is a 1.75 system. 1.75 system for a total of 7 modules. So 7 modules. So now I have array 1 with my azimuth and my tilt, array 2 with my azimuth and my tilt, the size and the kilowatts of that roof, how many modules on each roof. Can I fill out any information on my form? Absolutely. So additional system info, long wire run. Can I see if this is a long wire run? I'm going to exit Street View. This is going to take me back to the top view of this home. Which the internet is very, very slow today. the internet's a little slow today, so we're just going to go back to this. So my long wire run is normally when it's over 150 feet. I need to be able to account for that, especially in my pricer. We'll go over that later when we get to electrical issues. Homeowner needs to choose whether or not they want an attic conduit run, which means no exposed aggregate, no exposed conduit. I know it's not a ground mount system, so I'm going to put no. Any notes? We always paint our conduit, which is the conduits going up the side of the house. Attic conduit run, not sure. This is a homeowner if they want to attic conduit run. And then the long wire run, I'm going to say no because I know it's not over 150 feet. Well, that's it for roof design. Cheers to all. Happy selling.